So the topic is web architecture fundamentals. So when we say the web, so basically we are talking about web applications, websites, and definitely we will in next slides we will talk about what are the differences between web application, web sites, web pages. So I arrange this topic in so many slides so that I can explain it in a better way. And the agenda items are first we will talk about few slides. We'll talk about World Wide Web, WWW, and the evolution of web and what are the websites and web applications. What is the difference? And then we will move to web application architecture. And when we talk about the architecture is consisting of several things. We call them component. So in few slides, we will talk about web application architecture components, and then we will look into the why this architecture, web application architecture, is so important. And then in few slides, we will talk about how to arrange those components in the layer and how to prepare an architecture. And in the end, we will talk about the best practices when it comes to designing a web application architecture. So let me start with our first slide. So basically, most of the times we use these two words interchangeably, web and the internet. So are these the same thing or the different? I mean, yes, most of them, whenever they want to check their net connection, they just Google it and type something. If it is coming, net is working. But it doesn't mean that web and internet is the same thing. Actually, both are different things. So what was so before the World Wide Web? So World Wide Web was introduced later, but internet was exist. And so first we will talk about something basic things about the internet. So it all was started in 1960, and at that time the internet was used by most of the research organization, especially the government and the defense. And what is internet? So basically internet is a global network of connected devices and the networks. So it is a network of networks. And why they designed this internet? Because at that moment, not advanced, but computers was there so that they can store and process information digitally. And but there was no way to share data between these between computers. So they come up with this networking facility, and they connected, and this is how this internet was evolved, developed. And there were several ways to access the information over the internet. They developed different protocol for different kind of activities. So you might heard about email SMTP is another, and FTP for the file transfer. And right nowadays you might heard about the HTTP. So there are several ways how to access information over the internet. So basically, over the time, I mean, it was started in 1960, and over the time, around till 90 or 91 or 92, internet had so many user base and machines was connected. So almost 1 million host was connected by the time of 91 or 92. So it means internet was there. Information, it was a information sharing model. But what was the problem? Why did they come up with World Wide Web? Because before the World Wide Web, information sharing was possible. So the answer is because information sharing was not easy. I mean, that the information it presented was not graphically well, and there was and the interface, the software they were using, the command lines they were using, that was not that did not has graphic user interface like today we use. So as a common man, it was difficult to access information over the internet. And that is why they come up with the idea that they need to develop something so that information sharing should be easy, and even common man, non-techie person can access information easily. Like today we all access information over the internet by website, by applications. At that time, protocols was whatever protocols was available at that time to communicate with the internet between devices. Those protocols were complicated and was not suitable for a layman or common person, or non-techie person who is not well versed in those technologies. And at that time, one more thing, at that time, most of the information was text based, not like today we are dealing with videos, images, and document PDF. So that's why they come up with the idea that we need to develop something graphically rich application, graphically rich content. So this World Wide Web and the web, we call it, this is a graphical interface for the internet. And it was started in 1989 in the CERN. CERN is a research organization in the Europe. And Sir Tim Berners-Lee is a British scientist who was working with the CERN, and he proposed the idea of this graphical interface for the internet, and they invented it in 1989. So we use these words interchangeably, www, World Wide Web, and both are the same thing. But internet is different. Internet is different. So this is one of the way we use internet to share information. So again, this is the same. It is an information share model, and it is built on top of the internet. I mean, it uses the internet. And definitely, because with the existing protocol, it was not possible. It was not possible to share information. And they developed a new protocol, HTTP protocol, to transmit the data over the internet. I mean, you might also think about what was the first website and how was it look like? Is it still accessible or not? I mean, do you guys know, if anyone aware that what was the website? And if no, no big deal. So as I mentioned, that first website is still accessible, and I can open it and we can have a look. So basically, as I mentioned, this CERN organization developed this first website, launched this website, and its URL was info.cern.ch. And it is still accessible, not in the exact form that was developed. Yes, they revamped it a little bit, but it is still available. And at that time, they launch this website with the help of Next Computer. Next was the company at that time that developed computers. So they use Next Computer to run this this website on a server. They call it, there was one application, they call it web server, and this was the first website, first web page. I will try to open it. And so while they came up with the idea of, they said that this is our first website, this is the first website. And so they said that this is a collection of web pages, and that are publicly accessible, and under a single domain. So basically, the idea was that user can access it from their machine, and with the help of some kind of software. So they call it, this is on client machine you should have a web browser, and on server we hosted it in a machine, and that machine contained one application that they call it web server. And this is how our web browser will be able to connect with the server, with different machine where this application was hosted. And so it was the overall idea. And so basically, to cater the first website, uh, it was not possible to develop a website with the at the time with the existing technology they had at the time. So they developed few new technologies like HTML. HTML was the one that we used to develop a web page. So HTML was the hypertext markup language. And as we previously mentioned that website is a collection of web pages. So definitely in a website we have more than one web page, and all page should be identifiable. So they came up with the one technology, they call it URI. This is how they can distinguish address of each web page. And and as I mentioned earlier, they develop one new protocol. They call it Hypertext Transfer Protocol, HTTP. And to host this website, they come up with one software. They call it web server, and this web server is should be available inside a server application, server machine. And as websites can be accessible through internet, but you cannot access the website directly. You need a software that usually nowadays we call them browser. So they develop one browser, so Nexus. So these 4-5 new technology developed during 90 by Sun with the help of Tim Berners-Lee, and this is how our first website came up. And so let's have a look in detail how we access our any web page, any web application, and how it look like. If we picturize this communication, then it will look like this, as you can see. So here I try to separate these two aspects of a web application with the help of this dotted line. I call it internet. So this is not just a line. So this internet resembles the network. This is how our client, when I say the client, it is a client machine, like a user machine. The user is trying to access this application through a machine, and server is a machine where this website is hosted. And as previously we mentioned, that in the client we need one software that is a browser. So here I use one symbol for as a browser. And in the server, again, you need one software. We call it web server. So it is a Tomcat web server. So this is how client machine communicate with the server machine with the help of softwares. Client use browser and the server use server, and web server hosts that website. As we know, the website is a collection of web pages, and this is how this client server communication happen. Developers host their website, the web pages in a server inside a web server. And this is how, if user is connected by the internet to that server, then they can access whatever information is provided by the website. So this is kind of a client server communication. And server is one, but client could be a number of client can access the server. And definitely we cannot access any website without the internet. Internet is a medium to access the web pages. I want to make this session interactive, so you all are open to raise any question, query, and we can talk. If needed, we can alter this session. I mean, definitely we can introduce. I cannot introduce new slides, but definitely I can speak about, and we can skip few slides if I feel that those slide doesn't make any sense. So, any questions so far? Or if I am speaking too fast, then I can slow down myself.
Sir, it's me, Amit Shukla. Yeah. What is hosting?
Hosting. Okay.
Yeah.
Okay. So hosting is, I mean, if in a common term, I will say, as I mentioned, if you want to launch a website, then it is not like that you just put those files or folder in one machine and you try to access over the internet. No, there is a process. There is several configuration was needed. We need some infrastructure. We need to deploy. We need to put this file and folder at a dedicated directory defined by a web server. So basically, while we talk about the hosting, it means First we need a machine, we call it server, and it could be dedicated machine, like we purchase a laptop or desktop, but usually laptop or desktop is not used as a server machine. It should be highly configurable, and most of the time we don't want to maintain that machine, because that machine should be up and running, connected with the internet, and you need continuous supply of electricity. So we prefer to go with the cloud options. So cloud is saying that we have machine for you, whatever configuration you need, you just need to pay us, we will maintain, and we will give you access to this server machine, and now you are free to use it as per your requirement. So while we say the hosting, we need a server machine, we need a machine, we call it server, and inside that machine we need to decide what operating system we want to run. And as we want to use this machine to deploy a website, so website cannot be accessible automatically. Website need one software. I mean, this as here you see in this diagram, this tomcat icon. So this is a web server software, and web server software tell us where we need to put this website folder and directory, all the files related to this. And this is how, so all these arrangement, if we need to do all these things, then we say that we need hosting, we need server, or we need to install operating system, we need to install such software, we need to deploy our files there. So this overall process is called the hosting.
Okay, sir. Sir, my second question, function detection, like function hosting. What is a function hosting?
Sorry, can you repeat?
Function hosting, sir. There are two way of creating function, like in JavaScript. Then
Okay.
how to
Okay.
inbuild.
So, okay, maybe I misunderstood your question. So you were talking about hosting, not the hosting. So if it is the case, then definitely I want to tell you that in JavaScript, function hosting or variable hosting is a technique. I mean, it is more related to JavaScript, and this is so basically browser executes our JavaScript. And so suppose there's a file and that contains JavaScript code, and code is consist of statement line by line. And basically while browser execute it top to down. So if you define your variable at the bottom or in the middle, but you are trying to access your variable at the top, then they come up. I mean, this JavaScript came up with the idea of hosting it. It read a complete file but doesn't execute it. It execute it top to down. And so basically wherever it find any definition of any function and the variable, it virtually it keep it on the top. So that is function and variable hosting in the JavaScript. So we can continue from here. So now we know after this slide, we know how we access any website, web pages through a server by the internet with the help of client client machine, with the help of browser. So I mean, now, as you know, it has been more than 30 years while this first website was developed. And from that time to the till this time, there has been so much evolution on this on the web related technologies. So now industry came up with categorization of web pages. They call such web pages that was developed earlier, that was only read only. And you can see this is just a text based, and and it was read only. There was I mean the read only means there was no user interaction, and based on the input, content gets changed. Like nowadays, if you log in with your Facebook account, you see your profile, your content is customized. So it was not earlier, it was not such case. So if user can get access any web page the way it was designed, so they design this page and anyone can access the same view, will get the same view. So this was they kept such website in a category of web 1.0, and that was the read only. There was no interaction, and definitely in nature is the static website. So we will now, this was the snapshot or screenshot of our early days, very early days of web development in 90, I think in 91 or 92. And the next slide talk about the current state. So here you see I try to capture some statistics, and here you see more than 530 crores internet users, and such number of websites, and here you see, and on some icon you can see that email sent from today. So while I was preparing this slide, so there are several websites, several sources that can give you not exactly but approximate idea of such numbers. So I was preparing this slide in late 8 or 9 p.m. in the evening. So that day, such number of emails has been sent since morning. So here you can see the Google search since morning, and the blog post since morning. Twitter tweets has been sent from today, and the videos viewed since morning. So this is the current state. So it was not possible came from this single page web application to this state. Definitely HTML was not capable enough to handle all of this, all the features, because now you see videos on the Netflix Prime Video, you use Instagram and Facebook and other application to post your videos and pictures, you whatever you want to get the information. If you are not aware about direct, you don't know the name of the website, then you use search engine to search the information, like Google, you send email. So all this was possible because web is evolved in last 30 years. And this is, if web was not available, then internet definitely did not get such huge user base and such content that are accessible to each and every person, even the common person who is non-techie. If they know how to type, they can access the information if they have access to internet. So that's why I wanted to have this slide to explain the web evolution, because the web architecture is directly related to this. And while we say the web architecture, it is directly related to web application. And when we say the web application, it is directly related to what kind of application we need. What is the requirement? Requirement define each and everything. If we need just a single page, like sometime you have gone through some website where you see a single page of your kind of a resume or kind of a portfolio, or you just want to display your work. So there could be one or single page. So if we need to develop such website, definitely we need not such complex architecture for that. So it means the requirement define our architecture. We will look into next slides in detail. So as here we were talking about how we came from almost zero or almost this state to this state, and HTML was not capable enough. So after I think in 93, or 92 or 93, they came up with these two languages, CSS and the JavaScript. So CSS and JavaScript was not initially available. They were launched later, and over the time they introduced two more languages. And now if you see any website you cannot develop any website without JavaScript or CSS, because CSS and JS was introduced because there was some problem with the HTML, and HTML was not capable enough to do some feature. That's why they introduced CSS and JSS. So CSS was introduced to add style to the content that are available on the page. And how information available on the page? Because with the help of HTML, because HTML is a coding language and add content to any web page. Yes, Amit?
Sir, can I use Java and Python with JS? Oh, sorry, without JS, JavaScript.
Okay. So definitely you cannot develop any web page without HTML. Yes, it is possible. You can develop a web page without CSS and JavaScript, but there will be some limitation. Okay. And as you mentioned that Java or Python. So basically there is a difference. There is a difference. So far we did not talk about Java or Python, or I want to add few more name to this list. So these are not just two. There are several other languages like Node.js, Dart, and
React.
.NET,
Yes, sir.
and there are PHP, Ruby on Rails, ROR. Yeah. So there are so many languages, but all these are part of different category. We call them server-side technology, server-side languages. And the problem is uh, because when we say, while we access a website or web page through a web browser, so server sends some code to the browser, and browser is responsible to render it. And this is, let me just switch it to the browser. Let me just, I want to show something. Let me just, so as earlier I was talking about this first website. So this was the info.sun.ch. Let me just try to access again. And now you see this. And here they listed the snapshot of first website. So this was the first page they developed. And let me show you exactly while you try to access, whenever you try to enter this URL, or you hit any hyperlink that are associated with this link, you try to access this URL. So this request goes to client to server, and we are asking server that please give us this web page or this website. Okay. So we don't get information exact like this. No, we get information something like this. Let me again access and show you. So whenever we hit it, we get information something like this. Okay. And here
Yeah.
you see the response says something else. I mean, something
Yes,
similar
sir.
but not exactly. So it means it contains HTML, and this is how we compose our information with the help of HTML in such a way that it will look like something like this. It will look like this. So basically browser read this information that it received from the server and execute it, and this is how it transform this code to this look. Okay. Now the problem is, if you use Java or Python or any server side language, okay, so browser will not be able to understand it, because browser only understand JavaScript, CSS, and the HTML. Okay.
Yes, sir. Okay, sir.
Okay. So this is the problem, that you cannot use server side language. Yes, definitely server side language has a use case
But
nowadays.
sir, Python is also a scripting language. So
But
why
Python
want
is,
not?
yeah, Python is a scripting language, but Python is not designed to run in the browser. Okay, only JavaScript
Okay,
is designed to run in the browser.
okay, sir.
Okay, yes, Python, PHP, or any server-side language has their use case. We will talk about in later slide. In one statement, if I say yes, they do some activity that JavaScript is not capable. Like, I mean, if we talk about this web page, suppose this web page or any web page that needs some information from the database. Okay, so browser is not capable to make any connection. I mean browser, we'll say JavaScript or HTML is not capable to access database directly
Yes, sir.
without any server-side language. So in the server-side language in Python, you have to write some script, okay, that will communicate with the database, and your web page or your JavaScript will connect with your Python related code. And that's why we call them web services, something like this.
Okay.
Okay. Okay.
Yes. Thank you.
Yeah. Okay. So here we were talking about these two languages. Why? So in the next slides we will talk about in much detail about these two, because as I mentioned, HTML, CSS, and JavaScript are the core technology and things that are crucial part of any architecture. Okay, so basically, as I mentioned, the HTML was not designed to style a web page, and while they developed the HTML, it was not styling and designing and much visual look was not consideration. That's why they did not added such feature. But over the time, while there were so many websites was available, then requirement came, and requirement says that we want to, if the title, the header, and any paragraph should be styled in such a way. So I mean, definitely, if information is presented so well, it should be if it is attractive enough, and yes, definitely we get information, but it should be properly aligned so that customer see information, whatever information they see, and sometimes we just want to highlight, like we can take this example of this web page, this is screen, and you can see that here I'm trying to say that designing and styling was not even a consideration, and I highlighted it a bit, I mean, with increase the font, because this is the one statement that defined what was the problem with the HTML. And again, you see one subtitle and other information. So this is a kind of this task. If we need to arrange some page in such a way, then we need to come up with CSS, and that's why CSS came. So initially, while CSS and JavaScript was not available, and they were developed to do some specific things, so the developers who developed the HTML, they added some features similar to CSS, and after that, one problem arose, that it was difficult to manage the HTML because HTML was not designed to do such work. So that's why they dropped this idea and reinstated it in previous state, and they created JavaScript and CSS for dedicated tasks. So in the next slide, we will talk about the JavaScript. So so far we know that why we need CSS to add.
So style is like to function style is color wise.
Yes.
In body.
Yes, exactly.
Yeah.
Okay, and so you know about the HTML, you know about the CSS. So why JavaScript came? What was the issue? What was the problem? Because any technology evolve if there is a problem. If we are trying to solve any problem, so the problem was the HTML was not a programming language. So when we say the programming language, I mean, if you have basic understanding about any programming language, the language constructs are variable functions. You can iterate, you can define you can use a for loop, you can use the if conditions, you can use the switch condition based on the logic we want to apply. So such kind of feature came up with the programming language. So HTML was not a programming language. It was designed to structure a page, give a structure of. Okay, so that's why JavaScript came. So while JavaScript was not there, such feature was not there in the HTML. What was the problem? So problem was that our web pages was not interactive. So nowadays you see, you type something, you want to post something, you type in the text box and you click on the submit button. Okay, this is how you post on the Twitter, Facebook. You can upload video, images. Okay, and all these things, all interaction user do on that screen, on that page. But at that time it was not possible because HTML did not provide such feature. So that's why they come up with the idea of JavaScript, and JavaScript filled that void. Okay, and and JavaScript, one more thing. So JavaScript were designed to run in the browser, they, you as a developer, you write some code in the JavaScript, okay, and browser know how to invoke their JavaScript code while user interact. Okay, so yeah, so now we know about the CSS and JavaScript. While early stage, in the early stage, we see the static and only a text based read only websites. Now we can redefine websites, because now we know CSS and JavaScripts are available. So that's why I try to mention here that at that time web designers was restricted by the technology available at that time in order to generate creative and engaging website initially. Okay, and nowadays while we say the website, so it is default that we are using HTML, CSS, and JavaScript programming language, and any website is built upon these technologies, and they are developed to provide any specific information in the category of different web pages. All web pages are interconnected. Information is saved on the server, okay, and user can access this information. If user has access to internet, then they can access this information by browser on their machine. While I say the machine, it could be mobile, it could be laptop, it could be desktop, it could be tablet, any. Okay, and here, so this is we can I mean, this is a formal definition of websites, that how what technology we use, how we access it, why we develop a website. One more aspect of a website, that it was designed in such a way that it can run easily on all devices. There should not be any such, I mean, there might be some software that come up with some specific requirement, that if your machine doesn't have such a specification of RAM or such operating system or something, then you cannot run those application. So it is not the case with the website or web. Okay, you can run any web page, any website on your machine with the help of web browser with minimum specification, and that's why web page application become popular, because they did not come up with certain conditions. You just need an browser, you just need an internet connection, and you can access it. Okay, so you might heard sometimes. So things are evolving. You might heard, so far we only talk about website, and interchangeably we use web application. You might heard, when we say website, so there could be two kind of website: static and dynamic websites. Why we are talking about these? Because dynamic website might need different architecture, and the static website need different. So we need to understand what is difference between static and dynamic websites. So basically, initially there was only static HTML pages. Now while I say static HTML pages, so now onward, when I say HTML pages, I will not only talk about the HTML. I'm talking about HTML, CSS, and JavaScript, and this is how HTML pages are built upon these three. So okay, and in the later stage, maybe in 95, because in 95 some new languages came into the picture. Okay, and we say the server side technologies was evolved to cater some kind of a specific problem, to solve some kind of a specific problem, and that's why these languages enables these website such dynamics. So there is a difference between static and dynamic websites. I highlighted what is the difference between static and dynamic. So here you see, if there is any website that using only HTML, CSS, and JavaScript, no server side technology. Well, I say server side technology, I'm also talking about the database. I'm also talking about any web service. I'm also talking about any kind of technology, server side technology, PHP, .NET, Node.js, anything. If they are not using, this is completely static websites. One more thing. If there are I mean, definitely multiple user access this website, any web page. If a web page is provided to all users. I mean, if any web page, while a user access a web page, if that web page looks same for all the user, that is a static website. And this is not the case with our current generation of websites or web application. Today, if I access Twitter or Facebook or anything, those all are very much customized based on our preference. So it means they whenever they serve, they there might be the chances you and some of you are trying to access the same page, but you will see information as per your preference, maybe some specific information as per the configurable settings. So this was not the case the static website. If any website does not provide such feature, that is a static website. Okay. And so what are dynamic websites? So dynamic in the dynamic websites, here I mentioned that they are much complex. When I say the complex, they are dealing with complex features. They have backend interaction with the user. When I say the backend interaction, I mean they definitely, those websites took input from the user, and based on the input, they might be using any external web service, or using by external web service they are fetching some information outside their website, or those websites are using web services to connect with the database, and this is you see such content on the website. Okay, they are more advanced, they are using more advanced languages, as I mentioned. Definitely they are using HTML, CSS and JavaScript, but technology stack is much more than that. There are several other technologies are using in there. Okay. And yeah, display, yes, unlike static, they display different content depending on various factors. So as we already talked about it. And now, while we know that what is static and what is dynamic websites. So now the question is, because so far in this session I use these two terms interchangeably. Initially I was using website and web page interchangeably. So we know what is the difference between web page and the website. So difference is like a page, like a book. So book is equivalent to website, and the paper and the page on a book is equivalent to web page. So book is a collection of pages, and website is a collection of web pages. And while we talk about the difference between website and web application, so in the previous slide we talk about static and dynamic, but we were talking about websites. Now what is the difference between website and web application? So basically in the next slide here we are going to redefine web application. Now we are making distinct, I mean these are some items that distinguish an website as a web application. So basically web application is a dynamic website, and dynamic website with more functionality, with more interactive elements. So there is a line, a blur line between dynamic website and the web application. Sometimes we use them, call them, I mean interchangeably we use them. So nowadays there is no such static website. Most of the sites are truly dynamic, and that's why we call them web application. And one more reason why this application came up, I mean this web application term came into existence, because nowadays web is not the only medium. You use mobile applications, desktop applications, and with the help of, because if we talk about the Facebook, you can access Facebook on the browser, you can access Facebook from their dedicated mobile application. If you are using iPhone, then you can download it from their store. If you are using Android, you download it from the Google store. And yes, both will serve the same content, but technology are a bit different. So that's why to distinguish between mobile or desktop related native application, so this term came into existence, that here we are talking about the web application. So now no one use website term website. We mostly use the web application, and because most of the web application are almost 100% web application are dynamic websites. So as here I try to mention few points about any web page, how we define an entity is a web page. It should be dynamic. I mean, based on user input. Suppose you want to access your email, whether it's Gmail, Yahoo Mail, or any kind of email, you first need to log in because your information is protected. No one else can access. Okay, you are the only person, and those are restricted with the help of username, password. And while so the first page, you, me, or someone else try to access Gmail from the browser, the first page we all get the same feel and view, same feel and look. Okay, and because that was designed, that is common for all, and it come up with a form with user input and the submit button. And while you input your username and password, and the next phase, I mean, it verify us, it is just me, no one else, with the help of those credential. And the next phase you get, that you get the view of your inbox, outbox, sent email. Okay, you all know how Gmail look like. That is customized. While I say the customized, I mean, is page layout structure is the same, but the content is different based on the user. So while we talk about that aspect, that is dynamic content. And the user engagement, again, user engagement means, suppose whenever you try to open a email from the Gmail, and before opening it, it say it was not read. Once you open it, it marked it read. So there is a user engagement. You can delete it. You can do n number of activities provided that feature. This is I just take this example from the Gmail. You can apply it on any today's web application. Those are more interactive, engaging platform. Okay, and obvious CRUD operation, creating, reading, updating, deleting content. If they are providing, most of the application are providing such. You can add your status, you can add your you can message someone, you can delete that on the Facebook, something like this. Okay, and complex functionality, yes, those are pretty much very complex. As a end user, we just type the name of the website or hit just one link, and we get the information. But it is not just two-step process. You click it and you get it. No, in the background, there are so much code, so many things are happening. Those take input, fetch input, different sources, process it, arrange it some certain order, and then pass this information to the browser. And even nowadays, browser are capable to execute JavaScript very well. So they take that input. It might be the chances that the information server is sending to the browser that are in certain format, but while we present that information on a web page, it looks different. So there are much complex functionalities are there. Definitely those are customizable, scalable, and frequently update, highly functional and user oriented. So yeah, so this is these all these items define a web application. So now we know what is the difference between a web page, website, static website, dynamic website, and now we know the web page. Web pages are just a advanced dynamic website. And if we talk about current scenario, so these are familiar logo icons. You all are aware: Facebook, Gmail, Twitter, Udemy, LinkedIn, Netflix. Okay, and these application come up with their dedicated service. We all know Udemy is in business of digital learning. You can access any course, you can purchase course, you can view videos, text there. LinkedIn for the professional networking, Gmail for email, and Facebook, we know. Twitter is another kind of micro blogging. You can post something, you can like, you can read. Netflix is a video streaming. So all these come up with web application along with desktop or mobile application. And yes, they all provide similar content, but technology are different. Okay, so as here in this slide, I want to talk about the uses of web application. We almost cover in last few minutes how these web applications are affecting our life, okay, or helping our different aspect of life. We use, I mean, we just wake up and open the browser to check the news, or maybe while not just the browser, we use dedicated applications to check the information. So now web apps are touching our every aspect of life. I mean, you can see e-commerce, online booking. I mean, kind of there are several websites you can book your ticket online, IRCTC, or movie, book my show, online booking, and order e-commerce. I mean, Flipkart, Amazon. There are several web apps that are available to cater such feature. Education related, like I mentioned, Udemy, and there are several other, and online banking. We all use digital banking nowadays, and you just need to open the website and enter your credential, and you can access your account, and you can do account related, banking related activity, social networking, email messaging, calls, job search, nokia.com, entertainment, news, real time updates. I mean, there were several news related web application, file transfer. While I say the file transfer, so I'm talking about I think that one. I mean, Microsoft also come up with OneDrive and Google Drive. So those are the web application. You can just drag and drop, or upload any file or folder, and this is how they store your information. You can access it anywhere. And navigation web applications like Google Map, advertisings, games. There are several online games can be accessible through the web page or web application. Nowadays you can see Dream 11, another web application that allow you to play cricket related activities, okay, blogging, and in this corona time, we all are using, we are working remotely, and most of the time we use Zoom application. Zoom also came up with as a web application. So I mean, from since morning to till night, each we do several things on these web applications, okay. And why I added this slide, because I wanted to show you a difference between each kind of application. I mean, each application is different in terms of functionality and feature, and that's why if I named here more than 30 application, but it might be possible that all 30 has different web architecture. Yes, there are some common things, but based on the requirement, based on the need, because as I talk about something like file transfer or something, if any website has a feature, you can upload any file. Sometimes you need to upload the resume, you need to do something, file uploading. So browser takes your input, your file, and pass that file from browser to server by some medium. And definitely server should be capable to handle this request, take this file and store it somewhere so that it can be accessible and readable in the later. So this is one example of feature. And if you are going to introduce such feature, definitely your architecture should be able to adjust it, because it come up with some maybe because you need some kind of technology that can process file handling, and the server side you need some kind of storage, so that you can store these files somewhere in the cloud, or in any dedicated location. So it means it added couple of things in the picture of architecture. So any query so far I want to discuss, I'm ready to answer if there is any. Otherwise we can move on to next slide. How much study should I do to make a website and technical skills? Okay. Yeah. I mean, it depends. One thing, it depends on person to person, but there are few basic things. I mean, as in this session, if you are completely new to a concept of web development, so definitely first you need to learn basics of HTML, basic of JavaScript and CSS, and at least a steady website. You can, I mean, it may take a few weeks. If you want to be proficient, you want to be expert, and you want to take a job in the market, then definitely at least 3-4 months you need to learn each and everything, every aspect of development. Because nowadays, here we are just talking about website. There are different aspect of development. So when we develop our application, you might be aware or not aware, it is not just a code. You need to manage the code. So we use software, Git software, to maintain our code versioning.
Yes, sir.
So yeah, so all these things take time. Yes, I will say, if you spend 2-3 hours, I will say in next 3 to 4 months you will be capable to building not just steady the dynamic website, along with some server side technology, and some simple database related interaction. Definitely you need 3 to 4 months.
Thank you, sir.
Yeah. Okay, so I added couple of slide again to show the difference between then and now. So here you can see, so you can get some idea uh, where we are now. So the Wikipedia, when it was launched in January 2001, then they came up with this UI UX. Okay, now now if you see the landing page of Wikipedia, then you will get similar something similar to this. Okay, so this is one snapshot of then and now. Another one is, and definitely it is not just the UI what you see. There are several things behind this, the technology they use the first day and the technology they use now. There might be there might, I mean, definitely they upgraded themselves, or they re-architecture themselves to cater current need, and you to use latest technology and technology stack. Another one is YouTube. So YouTube, while they launched YouTube, it was something like this. And here you can see that one logo, few menu icon, and the page came up with some username and password. So it was look like this, but now something like this. Okay, so I mean, definitely there were so many technology evolved over the time in last 10, 12, 15, 30 years period, and we are here now. And so while we were talking about, as we talked about web evolution, and so here I'm trying to mention that we can categorize our websites or web application in these three category: web 1.0, web 2.0, web 3.0. And if you see the description here, and in the single line, I will say web 1.0 was read only, web 2.0 is read and write, and web 3.0 is read, write, and execute. So as I mentioned, in the web 1.0, it was read only, there was no user interaction or much interaction. If you ask me that can be put a website inside the web 1.0 or web 1.0, I mean, lines are sometimes blur, because this is not something like that. Web 1.0 is started with the 93 or 92 or end in 95. No, this is not like, I mean, things are going in parallel, because if someone doesn't need any such feature that we call that belongs to web 2.0, then they develop website according to their need, and we put such website in this category because they are not doing much things. Okay, Amit, any query?
Sir, Web 3 is a full stack?
uh
Can I call? Like
No,
to
no, no, no. So let me try to answer this question. So you use a term full stack.
yes, sir.
Full stack is not directly related to any web app or web application. It is a capabilities of a developer. Okay, if you apply for a job, or any company or any project is looking for a developer, and as an suppose I'm working there as an architect. I'm responsible. I define all the technology, I define all the components, and I club together and I presented this picture that the application we are going to develop, it will follow this architecture. Okay, so based on that, we also identify, sometimes not exactly, but we know what kind of technology we are going to use. And while it comes to technology, one person, most of the times one person cannot learn each and everything. Okay, and in the market you have seen, we say this is web designer and this is web developer, this is that person is can work on Angular. Yes, Angular is based on JavaScript. So it
Yes, sir.
sometimes it happen, if you are a good programmer, if you are an Angular developer, so it might be chances that you don't know anything about the Python on the Java or PHP, or maybe even sometimes inside the client side technology, it might be you are not good in HTML and CSS. Okay, yes, but one thing is definitely sure, that you are a good JavaScript developer. That's because Angular is built upon JavaScript or TypeScript. Okay, so one person cannot do each and everything. That's why in a team, in a project, we have different kind of role. Okay, I mean, we define that to if we want to develop this application in next 6 months, we need one UX person, or maybe two UI developer. Okay, we need three Angular developer, we need one database expert, we can say DBA. Okay, or we can say that we need two server side server side developer who can work on Java or related technology. Okay, so we have different kind of role, and this is how we build a team, and they work together, and they are assigned with different kind of work as per their expertise. But sometimes, I mean, this trend was started in 2000, 2000, not exactly, but around 2012 or 12 13, where market came up with the idea that we are looking for full stack developers. So they want someone who can work on all aspect of the application. They can work on UX, they can work on UI, they can convert those UI into HTML CSS, and they are proficient in JavaScript. Proficient in JavaScript, they definitely should know React or Angular or any framework they are going to use. And for
Yes, sir.
database interaction, they must know database, they must know. So full stack. So this is the scene.
I'm getting your point, sir. I like to develop both client and server software.
Yeah.
Uh, yeah. Okay, sir.
Okay.
Thank.
Yeah. Okay, so we can continue on this. As I
Yeah, yeah.
mentioned,
Sure.
Web 1.0, Web 2.0, and Web 3.0. So these are few basic difference here. You see in the right side picture, it say that in Web 2.0, it is more most of the website we have seen. Like, I mean, it was. I mean, you might be aware that before Facebook we had Orkut. Orkut was the first famous social media site, and similar to Facebook today, there were so many features that user can interact. Most of the features are similar. Okay, so most of the websites that are related to social media, that comes under the Web 2.0. And because the content is user generated, there is a difference. If we talk about the content in the Web 1.0 and 2.0, in Web 1.0, the person who want to launch a website, they decide what kind of content they are going to present as per their audience. But here while Facebook or Twitter or Insta or anything was launched, it was blank. Okay, it was blank. There was no data, no data. This is how first user joined, the second joined, and they started interaction, and they generated content. So here the difference is, in Web 2.0, user can generate content. I mean, those applications are more interactive. They work upon user input. Okay, and definitely nowadays we all have mobile access, and screen are good enough, touch enabled. So most of the time, if I need to search something not in the application, on the web application, so I just use the mobile browser, and just those application, those are enable mobile access, then they comes under Web 2.0. Okay, and yeah, other things are global internet, high speed communication. In Web 3.0, it is a bit complicated thing, maybe not suitable to explain right now, but it is a next big thing, or it is wrong to say next big thing. It is still happening. It is still happening. I mean, there are application in the market. Like, I mean, you all might have heard about blockchain. You might heard about blockchain. You might heard about Bitcoin, or, or any digital currencies. Okay, and NFT. You might heard about NFT. I mean, there is a painting. They have its digital version, and they sell it, and they say that this is a unique copy. And how it become unique? Because there are technology that can make any digital entity unique. Okay, so there are so many concepts related to this. And maybe in future, not I'm not 100% sure, it is not easy to comment on this, but in future, or maybe even in the current time, in future, our digital bank still, while we transact, they use all the security standard to process our transaction. But in future, there might be, they use blockchain or some other technology to make it more secure. If they do that, then these application comes under Web 3.2. So this is not like this. In 95, Web 1.0 was dead. No, still some application are following Web 1.0. Some are using Web 2.0. Some application in the market, not commercial. There are few, very few Web 3.0 based are. In the future, we will see more Web 3.0, less or no Web 1.0. So this is the difference between Web 1.0, 2, and 3. Okay, and the difference between 2 and 3 is user will have more control over the data and security related things. Okay, now we know enough about applications, web application. The topic was web application architecture, fundamental of web application architecture, or web architecture fundamentals. And we talk a lot, especially basic things. And I felt this is needed to come up on this page where we actually talk about architecture. So whenever, I mean, when someone read a statement or terms, web application architecture or web architecture, so we are talking about one entity, that is web application. We know enough about that. Now we are talking about web application architecture. So it means when it comes to development of web application, there are different aspects of this. Okay, and other aspect are development, okay, and testing, and designing, and this architecture. So this is the first step in this process, because in development we follow, in design we follow this architecture. And and so when we talk about the architecture, most of the times, when talk about architecture, they will think about building. Okay, before any before websites or web web application, whenever someone talk about the architecture, they are talking about some kind of building. So like I try to add here one example. There is a villa house, and they definitely they had something in the mind when they connected any architect, and architect suggested this such architecture, and the construction company followed that architecture and they developed it. Okay, so if I here, this is a 3-floor villa, and this is so when we talk about the architecture, so it is a kind of map, it is a kind of a plan, or something presented on the paper. And this if you see it clearly, they mention here that where is the parking, where is the entry, where is the guest bedroom, how many floors are there, and each floor might have different map, different plan. And basically when we talk about the architecture in terms of building, so they are talking about how to organize all elements of a building, and so that function, it can function properly. Okay, how one component is connected with other. So this is I try to add this snapshot so that I can give you real world example of architecture. Now we are going to look on the web application architecture. Okay, and here I'm trying to define the web application architecture. So as earlier I said, web application architecture affected by our requirement, and what kind of application we are going to develop. But one thing is very common. In the previous picture, I will show again. We have seen two aspect of an application, two part of an application communication, that is client and server. And so in one line, if I say what is web application architecture, so web application architecture establish the way client and server are connected. Okay, and definitely in the client side there might be some component, on the server side there might be some component, and while we are dealing with those components, we need to define their communication, their link, who is going to interact with whom. Okay, so we will see them in later stage. Other formal definitions are web application architecture is a structure that define how an app is organized on different labels. So here they use here I use one term, different labels. So I mean in layman, until we see the next slide, we can say this client side is one label, server side is one label, and here we are talking about how we connected things at different label. And the next statement is saying architecture of any application is an skeleton, backbone of an application that supports the app fundamentally. So any you can if you arrange things in any order, definitely it is an architecture. But it might be there are might be 100% chance that your application architecture is not proficient, because you did not think too much about it, you just put something and connect together. So an application architecture should develop in such a way that our application can work proficiently. So other thing is the same thing, the describe different interaction taking place between components, middleware, database. So here we are, I'm going to introduce a couple of more terms. In next slides you will see more things, so that actual elements of an architecture. So due to such, because here in this statement we are talking about the interaction between components, middleware, databases, user interface, and due to such interaction application work together. Why we have all these? Because we want to see our application is working functionally, what was intended to do. Okay, and another couple of other statements saying the same thing. They are just trying to explain in better way. An architecture deals with flow and the communication of the entire application and handle the major aspect of the component. And yes, while we design a architecture and we connect different part or different component, then definitely we should define those component those elements logically. I mean, we should define in very logical way. Okay, I will show you what I'm trying to explain. Okay, apart from this, yeah, so it determines the future design of the application. Obviously, when it comes to development, we will follow the architecture, and if architecture is not designed properly, our application will not work properly. So in the earlier slides, we say this is client, and an architecture define how client and server interact. So again, I will try to explain it, because our next slides is going to be much complex. If we know this, then we will know those slides in detail. So basically, when a user try to enter a URL of a website in a browser, then and hit, so basically our client machine, with the help of browser, try to connect with the server with that URL, and this server should be capable enough to take that URL and give content against that. So it is a request and response communication, client server communication. With the help of request and response, it communicate by internet. Okay, now we will see things in detail here. So so far we were talking about abstraction. We did not dig into in detail. We just talking about client and server. Now we will see in more depth. So as in the previous slide, I say the client make request here. I try to show that it is requesting for a web page, and how server process it, and what is inside the server. While we say, so in the server machine, we have this web application server software. Okay, inside the web application server software, we have this web application, and inside the web application might be consist of two different kind of code. One, we are saying that it is built with HTML, CSS, and JavaScript, and we say that this is front end code, and other code is the backend one. Backend one might be the Python or any other server side related. Because why we need it? Because our front end side code is not capable to directly access the database. Here you see I tried to put database and third-party API outside the server. So might be server database can be part of our
Sorry, sir.
Yeah.
Sir, what is an API?
Okay, so API is something, I mean, okay, API could be external or internal also. So API is saying API comes with one route, or in layman terms we can say one URL. Okay, so API is saying you can access information even without a web page. I mean, there are several other way you hit. I mean, I'm not sure if you heard or not. There are several REST client or SOAP client, some software other than browser, and they take URL, and they hit the URL and they return the information. Okay, so we can, if you need to present your information visually, then you need to develop web application, okay, website. If you just want to share your information, you are not responsible to design your content, then you develop API. And API, definitely API also have a URL like a web page, okay, but those cannot be directly accessed through the browser address bar. Okay, and why we need, suppose there is a website, I mean, suppose you want to launch a website that provides some feature, but to provide this feature you ask user Aadhaar ID.
Yes,
okay, Aadhaar number, and definitely Aadhaar is a sensitive information, and government does not provide you. So basically government, I mean, you cannot have information related to Aadhaar, but you need to verify something. So government has some server, I mean, they have some application that expose API. So they are saying, if you want to verify, we can verify your Aadhaar card. Okay, yes, we can say it is a valid or not. Okay, so you can use this API in your application, and this API require, I mean, you need to pass this input Aadhaar number, and we will send you it is a valid or not. So
like to security purpose.
yes. So
Yeah,
it could
okay.
be external API. Sometimes in our application we develop. I mean, like that becomes part of that comes under backend. Okay, if we are talking about the internal API, okay, that most of the times we kept inside the. I mean, virtually we call them that is backend part. And why we develop API in the next slide you will see some of the architecture we follow them. Okay, and basically UI
Mm.
communicate with the backend server with the help of API, and this is how we need not to reload the page. Sometimes you click on the page and you
Yes, sir.
see
Yes, sir.
page is not refreshed, only certain portion is refreshed, and this becomes possible with the help of API.
Okay, sir. Thank you.
Okay, so here I try to add crux of our architecture, web application architecture. So web application can be of different size or different complexity level. Earlier we have said, but all follow the same architecture principle. But details may differ. I mean, while I say the same, so I'm talking about both our client server. When I say the client server, so definitely there will be some front end code, back end code, there will be some database if required. If there is an external communication, there will be third party API, there might be single third party API, there might be your application is dealing with different kind of API. So all are dealing with similar kind of thing. That's why here I try to mention that all follow the same architecture principle, but details may differ. Okay, now here uh, can you see this screen clearly?
Yes, sir.
Okay, so here you will see this is more complex. So that's why I mentioned is advanced web application architecture. Now things become complex, but still you can find few things that are familiar. You have seen in previous screen, or you might know, like the web browser. We already talked about in previous screens. We are talking about mobile, or instead of mobile you can say the desktop or anything. Okay.
So this is a ER diagram.
uh, so when it comes to architecture, if I pass, if you want me to design a architecture, so definitely I will define, and each and every entity I will say that if you
Yes, yes,
ask
sir.
me what is load balancer, I will say I will definitely define the load balancer, what is load balancer, what is his responsibility, and where load balancer will come into the picture, and how load balancer will took the input, and how load balancer pass its output, and okay, and in which layer I'm going to place it. Okay, but if I give you all this information in terms of text or document, so it is not easy to follow. Okay, then
Yes,
then
sir.
we came up with such kind of diagram. Okay, so this is not a ER diagram actually.
Yes, sir. Okay.
This is graphical representation of our web application architecture. Okay,
Okay, sir.
and the reason why I wanted to put it here along with this simple one, because I want to show you the complexity. I mean, this most of the complex application follow this kind, not exactly but similar kind of like here you see at the top in the left side, you see the user, and
Yes,
user
sir.
with the browser mobile, and they does not directly interact with the server. They go, I mean, most of the website, all not most of the all website use the DNS is related to internet. I mean, our internet service provider use define it. Okay, and it connect with the load balancer. Sometimes we need not load balancer, because we, so there might be possible, if you're Google, if I talk about Google has billions user who's
Yes,
using
sir.
millions user using at the same time. So one machine is not capable enough to handle this request, okay, simultaneously. So there might be one machine, or maybe a group of machine, they call it load balancer, and load balancer know about all other servers that can serve the Google search. Okay, and so load balancer will decide where your request will go. I mean, this one web server 1 also capable to do the web server 2, but based on the ability of the traffic, they manage it. So load balancer is another entity, DNS other so the front end is available on the web server also. So there are several DB cache. If your application is dealing with caching, then DB cache will come into the picture. These are the database can be of different type: relational database, NoSQL database. Sometimes single application can use both kind of database, because we have different kind of requirement. Okay, so suppose when user interact, we track user behavior. Okay, so we need or logging. For logging purpose, we usually use NoSQL. For other actual information storing, we use relational database. So those relational database, NoSQL database, might interact with other kind of data warehouse storage, and there might be chances that we are not using. Suppose there is a file uploading functionality or something else, we are not storing those information on our server. Okay, so we are interacting with some Google Cloud or Amazon Cloud or Oracle Cloud or any kind of cloud service. Okay, we have subscription. As a developer, we know how to access them and store the information. Okay, so there might be, so based on our requirement, what is our requirement? The requirement will introduce some more components, some more things in the picture. And while we have several things, definitely we need to come up with a plan how these things are interacting. Okay, and here you see, as earlier we were talking about the web services. So here you see in the right hand side, there is a web service, and in the web service, I try to mention here that there could be SMS and mobile push notification. Sometimes whenever you deal with sometimes you get OTP. So how you get OTP? Because that application implemented some web service, and it might be there in house, or it might be using any external service to provide this feature. Email notification, messaging queue is another. Monitoring dashboard is another. Messaging queue, I just want to give you one line statement. Sometimes what happen, an application is there are several users, there are thousand millions user at the same time. Or might be that our application is not capable to handle all requests at the same time. And sometimes what happen, we just want to do something, but we don't need notification that it is done. So it means we are allowing server to handle it at their convenience. Okay, so in that case, it take input from you, but it will not execute at the same time. Okay, so they have concept of messaging queue. Message came into the queue, and based on their the messaging queue know how to process them over the time. And this is how you will get notification later. Because most of there are some feature where you just, suppose there is a heavy file. Okay, heavy file, and heavy file cannot be processed instantly. So you just upload that file, and you need not to wait for that notification. You can do other activity on the application while server is done with that file. It will notify you with the help of messaging queue. This messaging queue is the part that take the input, process at their convenience, and later it will pass notification. So there are so many things nowadays you might heard about. Those are very fancy terms. And excite us, business and intelligence, AI, machine learning. Okay, so there might be the chances in your application is using some kind of AI, some kind of machine learning. So while example is Netflix. You open the Netflix, and it give you suggestion. So how did you get this suggestion? Because it store all the information whenever you interact with their items. Okay, they know what you are watching, and you started, you left. Okay, they know that user started, left it in 5 minutes, might be user not interested. So they track each and everything about your interaction, and they store this data in different database, or in some maybe same database in different tables, and they process it in the background. And based on that, they know what kind of genre, what kind of movie, what kind of show you want to see, and that's why based on that they provide input. So it means it might be that in your application you have some certain portion, okay, those are designed for to do such kind of processing. So this is one of the component can be, and while we have it, we need to think about it, how our application, how user will interact. User is not going to interact directly, okay, user is not going to interact directly with such kind of component. User is just asking for the home page, and home page internally the api that give content for the home page, that api might be interacting with such AI ML algorithms or models, and they say okay, in normal scenario they say this is the order, but as per our ML suggestion they say no, you cannot pass this information, you just need to apply this logic on this, and now we added a couple of other things, and now this is the item we can suggest user. So this is how things grow based on your requirement. These components will grow and you need to adjust as an architect, okay. And so what are those components? We already have seen the components in the previous and this one, and here I'm going to about in more. So as we say the client side, so basically there are three main components in most of the application, okay. And those two are the primary component, the front end, the back end, and the database. And the front end is, you know, in the back end we already talk about a database also, but there are some other components also that are not directly part of our architecture but are supporting that. I mean, support, those are part of architecture, but those are not, those are supporting components along with these two or three. So web service is another, third party service another, caching service, cloud service, user agent, web browser, DNS, load balancer, we have seen in the previous diagram, okay. So all these things are also part of our architecture need to take care of these components, okay. Now because we have several components, and the so based on the feature they are going to provide, based on the kind of work those components are doing, we can arrange them in layers. So like here you see the front end, back end, something like this. So here here you see the separation of concern. So while we are dealing with complex entity, more than one entities, it is better to arrange them in some kind of category. So most of the application architecture arrange their component in layer: presentation layer, business logic layer, data service layer, data access layer. So in the presentation layer, the code that deal with the presentation of the information, okay. So mostly those are related to, I mean, Angular. If you are not using Angular or React or any Vue, you are just dealing with JavaScript. So any code that deals with JavaScript, HTML and CSS, that are part of the presentation layer. Business logic layer is something that can be executed on the server side. So anything, any code that is related to Python, PHP, Node.js, those comes under the business logic. And business logic, because they are interacting with other services. Presentation layer will interact with business logic layer. Business logic layer will interact with the data service layer. Our APIs, web services come under the data service layer, and our database comes under the data access layer. So we can arrange those in the layers. We can categorize on them. And so we know little bit about architecture. In the next slide I will show you different kind of architecture. But why we need architecture so important, we already know, but here I reiterate it with more formal definition. So here you see, I mentioned that architecture is the backbone that unites and organize all the web application components. And what does it mean? As a developer, as an end user, as an end user, I don't care that what is behind the scene. As an end user, I just want to see any application responsive, fast, provide offline functionality, okay. And if net is not working, then you can just save the information while it comes online. You get a pass to the server, okay. It should be user friendly, okay. So UX should be good, it should be responsive, fast, okay. And as a developer, as an engineer, an architecture should be functional. I mean, the application should work the way it was designed. and application should be it should not be our architecture is creating any problem that it is not easy to develop or scalable, or scalable means suppose our user base grow, and right now our application is using only single database. In the future we have to introduce more than two database, or more than I mean, like in previous diagram you have seen more than two server. So it should be scalable and it should be easily scalable. Our architecture should be designed in such a way. Also, it should allow automated testing, automated deployment. All these things should be catered by this architecture, and these all these things are the main concern of a developer or an engineer or an architect. Okay, and for the business user, business owner, and the stakeholder, they definitely they are more concerned about the profit and their business need. Whatever they want to convey, it is able to convey or not. It should be the highly secure. Most of the countries has security standard. If you don't follow, you will get legal notice or things. So your application should be highly secure. No one can steal information, and unauthorized users should not steal information. Easy to support. So these are concerns from different kind of users, as a developer, as an end user, as a business owner or stakeholder, that an architect took care of while they develop the architecture. Okay, so the crux is the type of web application architecture depends on how the application logic is distributed between client and server side. And so these are the type of architecture here you see. So web application architecture evolved over the time. So why I'm saying, because we have seen evolution of web application. Requirement came, technology came, things get changes, and over the time you have seen this transition. Okay, not in exact order, some overlapping, but you can see some application are following legacy. I mean, not while I say the application architecture type, so I'm also talking about the type of application, because type of application are directly associated with the architecture. So legacy HTML web application is following legacy HTML web application architecture. So legacy HTML web application, our initial application was legacy HTML web application. Then in the market, I mean, I started working in around in late 2008. At that time there were so many legacy HTML web application. Few were based on web 2.0, like Orkut or something. LinkedIn was, I think, launched in 2009. So okay, so in the market, while new kind of application came, so the problem was that in the legacy HTML web application, you need to hit if you need any new web page, you need to hit again. I mean, server browser request the new web page, and so yes, while they receive information from the server, it execute it and also change the URL. So page refresh was the problem. And while you request for new page, it send you each and everything: HTML, CSS, JavaScript, all images, everything. Okay, so it took time. So they came up with the idea that if possible, then it should be that if I need to see something in the right side of the page, in some section, I just want to see this change information here, why we need to reload the complete page if content is not getting changed. Then this visit web application concept came. Okay, so I mean, but it become possible because technology was evolved, and there was Ajax. There was one technology, Ajax was came into the picture. Ajax can be implemented with the help of JavaScript. And to implement it, I mean, JavaScript was capable to hit any web service, and based on the input, this web service requests data from the server, and server just pass the data, not the HTML. Okay, because layout was already there. We just need to refresh a certain section, or certain sections on the page, different sections. So different sections can initiate request for different data, no page reload. So this kind of application are visit web application. So what is the difference between architecture of legacy HTML and visit web application? few new components came into the picture. One of them is the web service. So definitely, if you are developing web service, you have web service related code. While you have a web service, there might be chances that you are dealing with the database or external web service. There are two more components, and you need to arrange those in your architecture. Okay, and this single page application, I can recall this came into the fashion in 2012 or 13 with the launch of Angular. You might heard now Angular, React, and Vue, but earlier there were few more. Those was Ember, Backbone JS, and maybe I don't know. There were few more. Okay, and why they came? They say that like you can access information over the internet with the help of Ajax, and you need to reload the page. That we can use the similar technology. How, I mean, it will be good if we need not to reload page again and again. Okay, only I mean, while we request server just send a single page, and after that moment, uh, with the help of this single page code, we have all the JavaScript code, and that JavaScript code is capable to handle all the data we need for the subsequent page. On all the subsequent pages will be able to catered by our client side code. We need not to reload or request the page. So it means there was a concept of, while we request the first page, that came up with some kind of template, and this template is responsible to decide what kind of data they need. And yes, you can see in the browser, you are suppose you switch, you click on the link and you see the page. So in the page, they come up with the technology that you can see the page change in the address bar, but that page change request was not hit by the browser, because browser know this is a client side route, and client side is capable to handle this request also. And yes, you will get content from that route on your browser, and need not to worry about. And transition is seamless because there is no back page change. Okay, in the background, you are getting information with the help of services. So this single page application is next extension of visit web application. Yes, someone was saying something.
Sir, could you explain me how to build in all of thing, like to wide, signal, progressive?
Okay, so I think you have to wait for a few days,
Because
because
sir,
my next
this
session.
topic is out of
Mhm.
bounds.
Yeah. Okay. So basically, my next topic is about developing a end-to-end application,
Yeah.
and I'm planning to develop one single page application. Uh,
Yes, sir.
okay, with the help of Angular, Node.js, I mean server side, client side
Yes, sir.
technology,
Right.
along with some other components. So my next session will be on this, and this is kind of a first
Information.
session in that series. Yeah.
Yeah. Okay. Okay. Thank you.
Okay, so over the time, there was some requirement in the market that application should be able to behave like a Android or mobile application. In the mobile application, you can do certain activity while you are online. Your data can be synced. So such kind of application is called progressive web application. If you are developing such progressive web application, you need to take care of some kind of local storage while user interact. Your request should not go to the server if you are not online. I mean, so there is some caveat. It definitely will not. Some certain extent we can develop an application progressive, but if you need some data in the real time, then you need internet connection. But yes, few things can be possible offline. So if we are introducing such feature, we are talking about progressive web application, and again, they come up with some additional technology. And micro frontend and microservice something a little bit complex, but those are extension. Why these things, micro front end, microservice, came up in the picture? Because nowadays everyone want to deploy their application in the cloud, okay, and they want to scale. And so scaling is only possible if suppose an application provides several features, and it is possible to develop those features as a separate module, and those separate module can be hosted on different server as a service. Okay, so one machine is not responsible to do all the activities. Different machine are dedicated for different perform activity, and this is how we can scale. And similar, if we implement similar pattern on the front end, we call it a micro front end. Suppose you have a web application that provide 4 5 6 feature. You need not to develop single. Definitely application is single, but you develop those features as a library, as a module, and those can be built and deployed separately. So these are more related to scaling, how you scale your application. And this serverless architecture is a bit new in the market. Not new, yes, applications are following it since last 3 4 5 year evolution after evolution of cloud. Okay, and so I next two slides, I don't want to talk much. I just want to show you a few things about serverless architecture. So a couple of more things here. As so we already mentioned about single page application earlier, we talked about. So while we do the first request, so from the server we are saying that all the logic related to presentation, all the code related to presentation layer in one go, while we load the application first time, that moved to the server to the front end. And after this, and this is the one time process, and after this no such call happen that will give you all the code. Because this code, this presentation layer related code is capable, browser is able to handle that. And we know JavaScript is able to deal with the API, and after that no subsequent page call. All pages will be served by this page without interacting with the server. Yes, on different page we place different data. So for that we use API request. So that's why in this picture there is a different front end related code we are showing in the client side, but actually it is on the server. First time while interact, then our client, our browser receive this code, and after that no communication. Now afterwards, front end is capable to communicate with the backend by with database and third party API by the API REST APIs. So this is a single page application. We already know about single page application. What is that? And this is a difference between single page and the traditional. I already tried to explain. If you want to see graphically, client is requesting a page, server return HTML. If client need another HTML page, client request, server again give you another HTML page. And this is how you see a page reload again and again if you are dealing with different kind of pages. That is traditional page lifecycle. But in single page lifecycle, client request, first time request, then server send an HTML page, and after that client does not ask for any page, because in that code what they received in the first call, that is capable to serve all the pages. Yes, all pages need data. So after those, on those pages, we request AJAX call to the server and get data in form of JSON, and client, our browser, our JS code is capable to put that information on the page based on layout. So this is the difference between a single page application and traditional page lifecycle. Okay. So I think I already explained SPA, single page application in detail. Is nothing else here, and there are some benefits. So because in the you are not going to hit page again. So speed, and it is a responsiveness, enhanced UX, because UX is more directly related with the JavaScript. If JavaScript is capable to do so many interaction, then we need not to hit server side again. So more JavaScript, more enhanced UX. And UX, not just UX, interactive UX is a bit different. cross platform compatibility, less resource consumption, because we are just sending the data, not the layout or something. Easy to debug. Yes, there are some drawbacks also, online threat, but there are some other ways to overcome those things. Yeah, so in the previous slide, I mentioned about one architecture, serverless architecture. So it does not mean that there is no server. Actually, server is there, but you need not to worry about the server. Those cloud service providers take care of all the server. You just need to tell this you want to deploy your application, okay, and they behind the scene they know how to where to put your code, and they define the server. So it means they come up with some kind of admin configurable UI interface where you can design your machine, something like this. So there is no dedicated hardware server. They are providing instruction. So it is not like that serverless doesn't have server. Serverless also has server, but they take care. We don't take care as a developer, as a site admin. Okay. So these are two examples I want to show at the last about serverless architecture. However, it is a bit complex, but I want to give you a glimpse of how things work there. So AWS and Azure is from the Microsoft, and AWS is from the Amazon, and they have their cloud, and their cloud provide different kind of service, like there are several. They also come up with cloud database. They are come up with the user authentication related module. They are come up with some storage, like you want to upload the file or upload the file, uploading related, storage related services. So they develop several services. What kind of feature you want, you can use service. You can pick service as per your according. And these are, you need not to maintain the server. You need not to maintain infrastructure. They all take care. You just need to focus on business logic and your code. So this is a new way of development. And while we are dealing with such application, definitely they are new, because in earlier picture there was no Amazon S3. There is no such user pool. These are new terms. While new component, new things will come in the picture, in as an architect, I need to take care of such new component, and I need to define its role and its interaction with other component. Yeah, so I think, so this is our last slide. I here added some best practices. While I say the best practices, again, it is the same thing. It consists of all the items, those three stakeholder, as a developer, as an end user, as a site owner. Okay, if these best practices, if we follow these best practices, we can fulfill those points. Those are defined for the dedicated stakeholders. Yeah, any query? I'm done. If any query, definitely I can answer.
No, sir. I have no.
I have doubt in second last architecture, sir. What was that? Second last micro front end architectures. Why they are used?
So sometimes if you are into web application development, you might heard about Angular. Okay, so right now we are using Angular 13 or 14, but it was started, I think Angular was launched, I don't know, I think maybe 9 or 10, but commercially industry is using since 12 or 13. So while they launch, it was based on JavaScript. Over the time it evolved, and they switched to TypeScript, and they while they launched web 2 Angular 2.0. So not just technology, there are several others, and they completely transform their framework. Okay. So while they develop it, suppose there is a scenario where your application is developed in Angular 1.x, and now you want to migrate. So it is not easy. It is not easy to migrate from 1.x to Angular 12, 2, 3, 4, 5, 6, because from 2 to till now, they all are following the same guidelines, and from 1.x to the lesser version, they are following the. So this transformation not easy. But if we are following this micro front end architecture, it give you, you can develop a page. You can develop a page where certain person can come from different technology. So it might be to develop a page where maybe, I mean, we can take this example. Suppose here you see any example, let any example, I mean, on a page, suppose you have a 3 section, section 1, section 2, and section 3. So it is possible you can develop section 3 in React, section 2 in Angular 2.0, as section 1 in Angular 1.x. So we can use different technology for a web page for a different section, and this is possible because we are using micro frontend. And basically micro frontend allow you to develop different module in different technology if required. Not just if you are not intended, there is no such use case where you have to use different languages or framework. Not languages, the language is the wrong term, because we know that all are using JavaScript. So if you are not intended to use different framework, then in the micro frontend you can develop your modules, okay, and you group them on the page easily. So this is a kind of modularization. If needed, modularization with different technologies.
Sir, so means we can use microservice in micro frontend or serverless also.
Even microservice UI doesn't care about server. UI just need, data by a service. So there might be the chances that you backend server expose one endpoint, and UI will hit this endpoint, and UI doesn't care what is behind this. So that endpoint might be following endpoint is the code that serve that endpoint might following microservice or might following any traditional. Okay, they don't care about it. UI will definitely receive data by that API. Yes, if they implement microservice, there are several other benefits, like it is easy to scalable, easy to debug, easy to upgrade. Okay, and yes, it is also possible that you can use micro frontend with microservice. You can use microservice with normal single page application, or legacy, not legacy, with the visit application. So there could be n number of combination. There is no direct relation. Yes, in the real world, if you really want to develop a website that is scalable and as per our current standard, your architecture should follow micro frontend at the front end code, and the microservice for the server side code, for backend code. So combination of both will work amazing well. And when it comes to, yes, if you have application that is using your architecture using micro frontend and microservice, and it is also possible you deploy your code in the cloud, and with few more things we add here, and it becomes a serverless architecture. So that's why I mentioned in the past, in the start of this session, that everything depends on your requirement, and requirement define your application, and application define your architecture.
Okay, sir. Thank you. Got it.